All right, Dale, you can go ahead and unmute yourself and get started.
All right, I'm going to hit share screen.
Go
Oh,
ahead. Go ahead. Try
actually,
again.
it says you've disabled it.
Go ahead. Try it now.
Okay, I'm going to try it again. All right. I guess that's the one I want. Actually, I can share the PowerPoint. Share. All right. And we'll go ahead and start the slideshow. Here we go. Again, I modeled the Tulsa Port of Catoosa, which is actually located about 15 miles northeast of Tulsa, Oklahoma. It's kind of like what we call Oklahoma's seacoast. So I'll go ahead and get started here. And, that's the port switcher triple nickel 555 shoving grain cars into one of the two grain elevators we have on the layout. Okay, at a glance, it was built by myself and my son, Sean. We started construction in March of 2017 in its present location. It's located in a spare bedroom, which is 12.5 feet by 11.5 feet. We have a long mainline run of 33 feet. The track plan was our design based off the actual Port of Catoosa. We used Atlas Code 100 track because of all the switching operations we have going on. Code 100 is very forgiving. And then we use a combination of mostly Pico, but there's a few Atlas turnouts in the layout. Currently, we're 100% complete on the track plan. We've got the electrical about 90%, which there's just some few things we're going to add in as far as crossing signals, some little eye candy, things like that. The scenery is about 60% along. And we actually set it up so we have a very high rail height. The layout rail height is 50 inches above the floor, which gives us the ability to work under it very easily. And it's still low enough we can reach into it and do our turnouts because everything's hand thrown. It just kind of makes it, you're looking more into it than you are down on top of it. We use Digitrax to run it. We have duplex radial throttles, and we also are running Wii throttles through JMRI. Our forwarding system is car cards, waybills, and work orders. So again, it's located in a spare bedroom. It's upstairs. We do have a restroom adjacent to the room, and we have a crew lounge. When we are operating, we can go in and sit down and visit, have a little fun. So far to date, I put on 25 approximately operation sessions. Probably that number may be up around 40. We operate through the NMRA group here in Tulsa and also through a club that we belong to. In meets, we've participated in ProRail 2019. We were going to participate in the layout design and operations SIG meet in Tulsa this past year, but again, COVID shut it down. And then there is a Tulsa Union convention between the Green Country NMRA group and the Lone Star NMRA group, which is going to happen now in October. We'll be running operation sessions and an open house as part of that. The prototype Port of Catoosa, actually I live above it, so I can look down on it, is situated at the head of navigation for the McClellan-Kerr navigation system. It receives barge traffic from the Mississippi, and basically we can hit any port in the world by water from Tulsa, Oklahoma. It was opened in 1971 and dedicated that year. As far as cargoes, obviously it will receive rail traffic, barge traffic, and truck traffic. And occasionally, I have seen some well cars come in with crates on them, which is kind of interesting. Here's a schematic of the layout. As you can see, when we designed it, we had to account for 3 doorways in basically almost one wall. So we ended up with a around the wall design with a peninsula down the middle to give us the extra, switching capability. If you look at the schematic, on the left-hand side would be the land side of the port, and on the right-hand side, the aisleway actually represents the navigation channel. So you can see on the navigation channel, we have 2 separate grain elevators. We've got a liquid feed bulk service. We have a 200-ton cross dock crane with a barge. And then on the north end, we've got steel manufacturing, the engine house for the port. And in the middle of it, we've got a Y, so we can actually turn everything. On the west side of the port, which would be the left side, we have a Hughes Lumber, which takes center beam center beam cars. We've got a team dock, and then we have a liquid bulk non-hazardous dock. And then up on the north end, again, we've got more steel manufacturing. In the far lower right-hand corner, we represent CF Industries, which is a liquid nitrogen fertilizer manufacturer. So we actually switched that in a closet. So we have a lot going on in a small amount of space. You can see there are 2 interchanges with railroads. On the left-hand side, the orange track represents the BNSF interchange, which would come off of Catoosa, Oklahoma. And on the right-hand side, there's a yellow track, which is the SKOL, which is a regional railroad that interchanges into the port from Owasso, Oklahoma. We have industries served. We don't have a lot of industries, obviously, because of the size, but we are able to utilize multiple locations at the industry for switching activities. If you look at it, we're looking at grain. We've got an east and west elevator, which includes the actual grain unloading at the elevator, as well as transloading of grains, as well as other materials to barges. We have bulk liquid livestock supplements. Toloma Stevedore, which is actually on the channel. They have a 200-ton cross dock crane for rail to barge loading and unloading. On the west side, we're back to Hughes Lumber, supplier of lumber and building materials. We have the port team dock and the liquid bulk dock, rail to truck transloading. No Klöckner Metals, which is coil steel, which we bring a lot of coil steels in cars into the layout. And we'll keep going down the list. Word Industries, which is on the northeast corner of the layout, is steel fabrication for industrial structures. They would get shapes, beams, things like that. Lico Steel is actually on that same siding, and it gets coil steel as well. And then, of course, we've got CF Industries, which is formerly Terra Nitrogen, and it manufactures liquid nitrogen fertilizer. In that facility, we will put hazmat cars handling nitric acid. We've got empty tank cars going in and full tank cars coming out. Car forwarding, since the port is a small layout, we started out with the standard 4-point car waybills. And really, we found out that since it's strictly an in and out operation, a single point waybill seemed to work better for our operators. And you can see here is a example of one. We color code the waybill based on the area that the car is going. You see a red band at the top that would represent one side of the layout. So new operators don't get lost with all the things going on within the layout itself. On it, we'll have the name of the receiving customer, basically an address, who it's coming in by, which would be the Port of Catoosa delivers it with their own locomotives. And then we also give them a lading. I've had people comment about that. It's like, yeah, it's always nice to know what we're hauling when we come in, or if it's empty or if it's got something in it. On the bottom end of that, you'll look, and basically we just flip that over and we color coded the interchanges at what the car goes back to after it's done loading or unloading at the port. So in this particular case, we've got a yellow band on there. We also tell them that, well, it's going to the SKOL Railroad, which will eventually end up in Owasso, Oklahoma. We've color coded them so they know which side of the layout the car is going to. Red is the east side of the layout, blue is the west side. So if it was a industry over on the west side, it would be a blue band at the top of it. So the operator would know automatically, okay, I need to send that over to the west. We use industry placards at every industry, so the operator will know exactly what he's looking at when he looks at that area. As you can see on this one, we've got Hughes Lumber and the team tracks placard up. You can see that one note is all boxcar shipments to use will unload at the team dock, not within the team track, not in the unloading track for use. That's actually reserved for center beam flat cars. And then of course we've got the team track liquid bulk facility, which is non-hazardous. It would handle things like Caro syrups and stuff like that going to bakeries and those types of cargoes. You'll notice that there's a notation there for a blue flag. We actually do use blue flags on the layout. Operations planning. We designed the layout to emulate actual rail traffic that we saw through observation going into the port on a daily basis. We had one exception, which is really the team track and liquid bulk dock. There's really not a facility like that down there. We've got a very simple method of deciding what rail cars we're going to use during a session. Normally, a session will involve about 20 cars plus or minus being switched into or out of the layout. And the system we use, again, I just can't see going into JMRI and putting all that in. So we just developed a system using wooden dice with the car types noted on the sides of it. And we actually have 10 dice for the SKOL and 10 dice for the BNSF. And we will actually roll those, and whatever ends up on top are the cars that are going to come in for that session. So we then pull them out of our car storage. We'll put them on the interchange points, and then we will bring them into the layout, or they will actually start on the layout depending on which interchange they're going to. When we stage for a session, all cars are changed out. I like to keep things fresh. I just like to see new cars coming in every session. So that's my personal desire, and it's satisfying for me. So typical session, even with experienced operators, will run about 2.5 to 3 hours. So we still have a lot of running. You know, it's not a real big layout, but there's a lot of stuff going on, and they seem to all have fun when they do it. Again, I mentioned, I've said this several times, we are a small layout, so we have to do things to actually slow a pace down. You can get operators that come in that like to slam cars around, and it's almost like a race. So we've added some things to make the pace go slower. A couple of the things are really the two main ones are derails and blue flags. At the derail, obviously the operator is going to have to stop and then get out and literally throw the derail, because we use two different kinds. We've got the Details West flip-flop that I am installing on the layout as I can find them in stock in places. And then we use a smaller homemade one that actually straddles the rail with a little sign on it says derail. So he's got to literally stop and remove the derail before he can continue on into wherever he's going. Blue flags. We do utilize blue flags on industries where people would normally be working around or under a car, say at the liquid bulk dock, at the CF Industries, any of the steel companies where they're unloading cars. There are blue flags in place, and they do have to stop at that blue flag and contact dispatch to have them get a hold of an industry representative to come drop the blue flag. The engineer is not allowed to pull the blue flag. So, and I'm the guy that's dispatched and the industry representative when the time comes. So they have to wait for me to come in, because typically I'll be waiting in the crew lounge for somebody to call. I try to leave them in here and let them run it and just have a good time. Safety stops, of course, obviously, if you're hooking up to a car, we encourage them to do a 10-foot safety stop. And then when they do couple the car, take a slow count for a few seconds and run air to the car and release the brakes. So again, these are ways we've just tried to make the session slower and extend it out just a little bit. The operations on the Port of Catoosa Railroad is really, like I said, it's just an in and out operation. So they're really picking up cars at an interchange point, taking them out, switching them in, and then bringing cars back to that interchange point. So again, the one-way way bill has everything on it, so they know where to take it. And once they pick up an outbound car, they know what interchange to take it to. Interchange locations, again, we have the BNSF, which is on the west side of the port, as it is in real life. And then we have the SKOL, which is on the east side. We had to move it because most of their interchanging is done on the north side of the port. We're actually set up to where we are sincere in the direction for the most part. If you're looking north, that is the direction the navigation channel runs through the port, north and south. So anything along the navigation channel is pretty well in the spot it would be. So the only three industries that are really out of place on the layout would be Klöckner Metals, and then Word and Lico. Those are more over on the west side. We try to, if we can't get all the cars in, we have a couple of spots designated as off-spot car locations. Those locations will contain off-spot cars. We also utilize a work order, and those work orders are hung at the entrance of the layout as the operator comes in the door, so he can see that, okay, I've got off-spot cars, I need to move them, or I need to move cars at CF Industry, move empties into the loading rack, or things like that. So it gives them stuff to do besides just moving cars in and out. Off-spot cars always have priority over inbound cars getting into an industry, obviously, because they've been sitting there. So again, like I say on here, the Port of Catoosa rail customers don't like paying demurrage on unloaded empty cars or having loaded cars sitting at their docks. So any tour of operations on the layout, everything is handled and picked up, delivered, or off spot, whatever needs to be done. Okay, we've got two areas of work like I talked about. We have a blue zone, which is the west side of the port. And again, we have color coded everything so new operators know that if they see a blue line on a car card, they're going to take that car to the west side of the port or the west side of the peninsula. The red zone always, is the east side. So we've listed out the industries so you can see what we've got going where. A workday typically or a operation session begins, the locomotives are at the engine house and the engineers will pick up their locomotives and head to the BNSF interchange. The BNSF interchange is always loaded with cars when we start a session. So they can start their pickups and switching outs and delivering cars. We have the north leg of the turning Y. So when we have a guy working the east side and a guy working the west side, they can move cars back and forth there, interchange their cars. They have to coordinate their movements working together, and it works out pretty good that way. So they're going to be shuttling cars inbound and outbound to BNSF or SKOL. And then about mid-session, we're going to actually bring in the SKOL port turn from Owasso. Switching crews will have to get out of their way so they can come in and do their work. They will need to be close where if the train needs help reassembling to go back to Owasso, there is a quarry 5 miles west of the Port of Catoosa called Green Hill Materials, and they do deliver cars there on a trailing switch on the way back. So they may need help moving some cars to the head end of the train or something like that, so they can make that switching move at Green Hill Materials. Again, we supply things to the operators just to make it easier for them. The work orders that again are hung at the entrance of the layout so they know, okay, I've got this extra work to do when I get started. We send out crew call notices. I will type one up for a date and a shift and email that out to an emailing list I have, basically detailing the, basically it's the invitation, come to an ops session. And then, we, the first ones to answer, get the slots. So we use rail schematics like the map I showed you earlier. Those are hung on the fascia board in about 4 or 5 locations around the layout. We have signs that indicate the locations of derails, blue flags, and key turnouts on the layout when we're operating. And the derails and blue flags are actually on the fascia board. And if you look back behind it, you will see the derail or the blue flag. So we try to keep it where they can see that stuff and find it easily. So, and then we do have an employee handbook. We hand that out just for fun. So, like I say, the typical operational session will last between 2 to 3 hours, depending on how the crew elects to work. 2+ hours as individual engineers, 3 hours as a crew of 2. So we can run it either way. I kind of like to run a crew of 2. We have a lot of guys that just like, hey, I want my own locomotive and do my own thing. So most of those days are just 2 operators. We are going to be extending the layout here this spring down a hallway and into another bedroom, which will represent the actual yard at Owasso, Oklahoma. And from there, we can connect to points into Kansas and southwest into Tulsa, Oklahoma, through the use of a staging yard and a little bit of proto freelance design. And we have the design now. It's a matter of just getting the bench work up and actually start getting track laid. We're hoping that we can have it operational by summer. And here's a few layout photos of the layout. These were taken by Ken Ellers here in Tulsa. He is actually spearheading the work on the Tulsa Union Convention that'll be going on in October. The first picture is the east elevator for Gavilon Grain. The second picture is the cross dock crane with the barge, which as you can see, we've got some cars there. Behind it, you can see sticking up is the west Gavilon Grain elevator. These are just a couple of photos. On the left is Klokner Metals. We've added a 20-ton crane to the front of it now, which gives us 3 locations to spot in there. We've got 2 locations inside the building, and then we have a crane out in front of it. So we can actually run 3 cars in there. We can designate, hey, we want spot 1, 2, or 3, and that's the way we have to switch it. The picture on the right is the non-hazardous bulk transfer facility. It's under construction right now, so we painted it brown and added some construction equipment to it. Here is the SKOL coming in. You can see the derail sign. That's got a flip-flop derail on it from Details West. Those work really neat. I've had a guy run several of them and kept asking me why his cars were coming off the track. And I said, well, did you find that derail there you've been going over? And he goes, oh. So anyway, they do work, even the small ones. And that's our SKOL engines. Those are SD40-2s that we've painted up for SKOL. The other picture is crossing Bird Creek, which is actually runs at the south end of the port. So we cross Bird Creek, and that is the Burlington Northern interchange point. I mentioned I'm going to put a plug in shamelessly for the Tulsa Union Convention, which will be in October. It is a joint session put on by the Tulsa Green Country NMRA folks and the Lone Star division of NMRA, which will be in October of this year. We're going to participate in that. We've got about 15 layouts in it that will be holding operation sessions. If you're anywhere close, I think it's going to be one heck of a convention. I don't know of anything that's ever been like that done in Tulsa before. So if you can make it, obviously, we'd love to see you. I'd love to see you at an open house. We will be participating. If you want to look it up, it's just the 2021 Tulsa Union Convention, and you should be able to find it online. And that really concludes my presentation, Eric. So I can hand it back to you whenever you're ready.
All right, Dale, I appreciate it. Let me go back. I threw the link in into the chat. Just going to go backwards through the questions. Does the SKOL train run from, hold on, does the one SKOL train run from the one SKOL staging track to the other, or does it turn?
It actually runs from the SKOL track inbound from Owasso is behind a view block. So you don't ever actually see it till it comes out at the north end of the layout. From there, it goes across the north, and then it picks up the cars on the east side. So yes, it does run across the layout and then back in.
All right. Traffic on the river is barges, correct? It's not ships, right? It's not that big of a.
It's all barge. It's all barge.
All right. Are all cars that Industries picked up, are there any that stay spotted? I guess.
No, we try to run everything in and out on an op session.
Okay. Do you have any pictures of the homemade derail?
Well, I'll tell you what. Okay, I'm not used to doing this on my laptop. I'm usually on the, that's it right there. I use some channels from Plastruct and
so can you turn it so it's,
yeah.
There you go. Yeah, that's better.
Can you all see it? Okay, I apologize. What I can do, Eric, is I can take some pictures of it and post it up.
That'd be great. If you send me the pictures, I'll put them up on the OPSEC site.
Yeah. And it's got a little sign on it that says derail. I actually got into an argument with a guy last time we operated, said, well, that's a blue flag. I said, no, it's not. It says derail. He says, well, it's blue. I said, well, the sign is. But you can take it down. You don't have to.
All right. Next question. Are the dice rolled between sessions and the cars staged on the interchange track at the beginning of the session? Or do the operators get to roll the dice and then set up the interchange tracks?
I do the dice roll. and then I try to balance the layout so the guys have about the same amount of work. I don't want anybody left holding the bag, kind of standing around, because people
Yep.
don't like that.
Yeah.
Here's the wooden dice right here. On this one, it's,
Yeah.
just about all the sides are T except for one says XM.
Got it.
So we've
And-
actually, like I said, we've taken and through observation is what we've seen coming in down there on the interchanges. That's how and this is a BN dice. We have SKOL dice. Most of those are LOs, tank, hoppers, either 2-bay or 3-bay. So, we've kind of balanced it to each railroad.
Okay. There were a couple questions about the number of people on the layout or number of operators and train crews. I think you said I thought I saw it was either three people or 3 crews.
Well, actually, we can run 2 to 4 operators at a time, depending on
Okay.
what they want to do. Most guys want to run just a locomotive. So we only have 2 available locomotives. So usually that kind of limits us to 2 operators at a time. We're going to try some changes up to where we can put 4 people in at one time. 2 engineers, which would sit more at the back of the layout on some really nice stools I just bought, and they would run the locomotives, and then the brakeman would be in the aisle, and they're going to have to communicate distances, when to stop, things like that. Actually make them work together more. It makes it interesting. We've
Yep.
run this remotely with the little cameras. I made a little thing to set on front of one of the locomotives. So I sat in the crew lounge and my son did the brakeman, and it worked out really cool. We had a great time.
Yeah, I love the train cams that Bob Rodriguez set up. Those were so much fun to drive with. And I know other people have as well. It's just the only one I've run with. So
well, if I could figure out how to make that work online, I'd obviously start doing that as well.
Yeah. Let's see. Regarding the port of Catoosa, how long does it take a barge to get from the port of from the port to New Orleans?
I'm not sure about New Orleans. I know from I have seen as much as 15 days going to the Mississippi and then turning back north. So probably about the same amount of time.
Okay.
Yeah.
All right. Are the dice rolled twice, once to pick how many go in, once to, let me see if I can interpret this. Are the dice rolled twice, once to pick how many go in and once to for how many come out?
No, again, like I say, everything switches in and out. So if a car is at an industry, it's automatically going to be picked up. So when I stage the layout, I roll the dice once, and whatever's sticking up, looking at me, that's what gets picked for that upcoming session.
Got it. Okay. Well, Dale, thanks so much for presenting. As people are always talking about, oh, well, my layout isn't that big. It's like, well, it doesn't have to be that big of a layout to be able to do good operations. So thanks again for sharing.
Oh, we have a lot of fun, Eric. Thank you
yeah.
for allowing us to present, and thank you for including us in the magazine. We're very proud of that.
Oh yeah, I think that was last issue, I believe.
Yes,
Okay.
In the January issue.
Yep. Yeah. So if you didn't get a chance to see it, Dale wrote up an article about this railroad in the January OPSIG issue. Make sure you go back and take a look now that you've seen the video. So, all right. Next presenter, I'm just going to find him here, is Dennis Drury. We're going to go ahead and unmute you.
I'm here.
All right.
So let's see if I can share my screen.
Yep, should be able to.
Yeah, share. There we go. I'll start the slideshow. Can everybody see the slides?
Yeah, it looks good, Dennis.
Okay,
Go
good.
ahead.
So just a bit of background. I gave this clinic at a convention of the Pacific Coast region back in 2015. It's still current as to what I'm talking about. I will say that I worked for the SP from 77 to 84. This is based on my recollections of that time, and there have been huge technology improvements since then. So after 84, I know it got a whole lot easier and a whole lot more computer oriented, but this is what I remember. So the clinic is rail detector cars, what they are, how they work, and how they affect railroad operations, both model and prototype. So what is a detector car? A detector car is a vehicle that goes down the track spewing little yellow slow order flags behind it. A detector car is a vehicle. Here we go. They come in many types, including on-rail cars, high-rail trucks, high-rail Suburbans, or even push carts. There are also track geometry cars that may include rail flaw detection devices, but they'll not be included in this discussion. And this was originally an hour-long clinic, but I'm going to try and speed it up a little bit, so I might go through some things pretty quickly. This is a Sperry rail system car. They're on rail, they never leave the tracks. They're custom built by Sperry, and they're pretty good at what they do. This is Southern Pacific high rail truck, the RD4. This is the vehicle that I worked on when I first started in the detector car lab. The gentleman with the white hard hat is my boss, Tom Hamada. I'm either behind the car doing hand testing or I'm driving. So can't remember, it was a long time ago. This is a car made by the Dapco company out of Danbury, Connecticut. Again, it's a smaller version. It's an on-rail, high-rail vehicle, kind of like a bread van. And I don't know, I think UP is still using something similar to these. This one's been retired. Here's an early example. This is a Santa Fe car, probably from the 30s or 40s. And it stays on the rail at all times. This is one of those hand carts I was talking about where you can test, just walk along and test as you go. Usually used to test switches, other places where the full detector car can't get to very easily, or for small branch lines or other railroads, they might use something like this. Okay, detection methods. They can use various technologies either alone or in I can't talk today. In conjunction with each other. They include induction testing. Induction testing is where you pass a high current through the rail and use a sensor to detect any anomalies in the magnetic field. Magnetic testing, where you actually magnetize the rail and look for anomalies. Ultrasonic testing, where you send a beam of ultrasound energy into the rail and look for reflections. Same frequency and a lot of the same technology that's used in medical ultrasound. And again, they can be used singularly or in combinations. This is induction testing. There's a big generator, very low voltage, very high current, feeds the current into the rail, and then the sensor is located between them to detect any abnormalities. Electromagnetic, you magnetize the rail and you have the sensor to pick up any disturbances in the magnetic field. Ultrasonic testing, I don't know if I can, there we go. So you have different crystals pointed in various angles to shoot a beam into the rail and look for reflections coming back. Component location, this vehicle uses both magnetic and ultrasonic. Here's the magnet. The carriage back here in the back has both the wheels with the ultrasonic transducers and the magnetic sensors to pick up the disturbance in the magnetic force. There was an ONAN generator that generated the electricity to run the vehicle, air conditioning, of course. This is why you have rail detectors, so the train crews don't have to deal with this. If you look very closely, you can see a defect in the rail that caused it to pull apart on a very cold night and out in the middle of Nevada. So types of defects: detail fracture, like this one, usually on the gauge surface of the rail up near the head. Transverse fissure is anywhere in the rail. This one's a huge, most the entire rail. Head web break, basically this part of the head just came completely off. Bolt hole break, where it comes through the bolt hole, can either go all the way through or is partial. Horizontal web, again, these are kind of self-explanatory. Vertical web, split head, horizontal split head, and a vertical split head. You also have defective welds. A lot of times they'll use those hand testers just to test welds after it's been laid in the field. Prototype operations. Detector cars mostly use maintenance away authority to occupy the main track. On timetable train order, the cars use a track car lineup and flagged where necessary. CTC, track and time was granted by the dispatcher. In some areas, like Texas, a conductor pilot was used and the car operated as a work extra. And there have been cases of entire branch lines being taken out of service for testing purposes. Oh, I can't read that last part because my screen thing is covering it up. So anyway, prototype operations continued. Testing frequency is determined by several factors, including annual tonnage on the line, presence of passenger trains, failure history, other special circumstances, and the frequency ranged from every 3 months to 2 years. Mainline tracks were tested as well as mainline sidings, but while the main might be on a 6-month schedule, the sidings might be done every year or every other year. Major branch lines, and again, this is SP specific, Coos Bay, Tillamook, and Modoc were on an annual schedule, but the sidings were not tested. Again, all of those branch lines did not have signals, and there were 2 or 3 trains a day at the most, but the sidings were not tested. Yard and industrial tracks were never tested unless specifically requested. When I was working for them, the testing was done while the car was moving between 4 and 8 miles an hour. I understand the speed has increased with the improved technology, but when I was doing it, you could see a lot of country at 8 miles an hour. When a possible defect was detected, the car would either back up and test again to confirm, or would back up near the possible defect and the crew would get out and hand test the rail. If a defect was found, the rail would be marked with the type, size, and defect number. Note that the equipment would shoot a dye marker on the rail at the site of a potential defect to make it easier to find when you're doing the hand testing. Track work through switches was fairly complex with numerous bolt holes, so the car would test through the switch twice. And because the carriage kept the testing wheels pushed up against the gauge of the rail, the carriage had to be lifted so it wouldn't derail over frogs. So for the most part, switches were done, at least in the later day of when I worked for SP, switches would be done entirely with those little hand carts. There was a gentleman that had a pickup truck that would drive to each switch on the line and get out and test it, put his thing back in the truck and drive to the next one. Model operations. Several model manufacturers have made rail detector cars in HO scale. They include Bachmann has or had, I don't know if they still have it, a step van type of the high rail car similar to the DAPCO car. I believe Walters has had several styles of Sperry cars in different paint schemes. Custom Finishing had a Herzog suburban style high rail car. And a long time ago, Overland imported a model of the early type of car similar to the Santa Fe car shown earlier. Simulating the operations of a detector car on your model can be as easy or as complex as you'd like it to be. If you have a model car, you can have it test during the day shift when most of the maintenance away forces are working. It will be up to the dispatcher to figure out how to fit it in between the trains. And remember, testing speed is under 10 miles per hour, but the car can move up to 25 miles an hour or even faster when running to clear an oncoming train. While testing, the car can find defective rails. At that point, the dispatcher will need to be notified so a slow order can be issued until the rail is fixed. This can take anywhere between an hour to 3 hours, depending on the type of defect and with how many defects the maintenance away forces have to deal with. Most defects require either a 10 or a 25 mile an hour slow order until they are addressed. Even if you don't have a model of a detector car, you can simulate their existence or the aftermath. Simply start an operating session with a list of slow orders left over from the day before when the car was working. Then as maintenance away gets them repaired, the slow orders can be taken down. As layout owner, it's up to you how fast your maintenance away troops are. And I'll end it here and we'll look for questions.
All right.
It's
We've got a
quiet.
couple. Got a couple questions out there. John Hansky was noting that the Sperry car had a C truck and a B truck.
That's correct.
Which
And
then,
if you remember the picture, they there was one truck that did the propulsion and the other truck that did the sensing, the testing.
okay. And then there's a question, Dennis, when using high current or any electromagnetic rail testing, do the signal systems or track circuits have to be deactivated?
Not necessarily. There were occasions where it would cause issues with the signal circuits, but for the most part, what happened is the maintainer would be on site if he knew a detector car was working, so they could repair any issues that might have come up. They may also have been on site because detector cars are notorious because of their short wheelbase to trigger the crossing circuits and then raise them back up again, so the gates would be pumping up and down and causing traffic problems. So maintainers would be out dealing with that situation too. But for the most part, the signal systems didn't suffer any damage.
Yeah, I was going to say the Sperry, I think it's like the box truck one. If you ever watch Virtual Rail Fan, those always make the highlight reels that they put together. You know, that they caught one going somewhere doing its inspections. So there's lots of. I think I've probably seen the box trucks more than the rail cars recently, but it's an interesting system they have. And I thought you did say that they use ultrasound as well, correct?
Yes, that is correct.
Okay, yeah. There was another, not a rail car, but I think it was CP put up. I have a photo of it. They're actually using, where's the photo of it? Oh, never mind. It's a different technology. They basically put up essentially a tower with sensors all around it to essentially scan the train as it goes through, looking at the rail cars.
Mm-hmm.
So sort of the other side of it, again, using the newer technology to check the trains as they're in flight. So, let's see. Let's see if there's any other questions here. Doesn't look like it right now. So, Dennis, thanks again for presenting. We appreciate it.
Okay, thanks, Eric.
And always something a little different to that extra little wrench, right? You don't always want your operating session to go smoothly, right? You want it to go.
Yeah.
Want it to be realistic. There's always going to be something that happens with the track, right?
And this is a nice way to slow things down for a day or two.
Exactly, or a session or two, or however you want to play it, but gives you a reason to grab one of those kind of very unique models if you can find one. So
right.
All right. Let's see. We've got a question here. Arthur's asking, what does it take to make a repair? Just cut out and replace a section of rail, make a weld, or what?
Yes, it can be both. It depends on the type of defect. When in the days of bolted rail, they would just unbolt one section, bolt a new piece in. They might put an angle bar across the brake, and sometimes if you'd see go along the track, you'll see an angle bar with no break between the rail there. That's what they did. It's basically protection in case the rail does break at a later date. Other times they'll cut the piece out and weld it back up again. It kind of depends again on the brake and what the maintenance way crew has available at the time.
Yeah, I've seen some amazing videos of them using thermite on the rail as well.
Right, and I showed one picture of one of those a defective thermite weld that pulled all the way apart.
Yeah, I mean that's some insane stuff. So, Dennis, what was your background? What was your background for getting hired for the SP job that you had?
Well, I first went to work for the SP in the signal department, And my background was an electronics technician. I later became an electronics engineer. So that was the background. As I said, I worked for SP 77 to 80 in the signal department, and then 80 to 84 in the detector car lab.
Got it. And I believe you said that Sperry is both the manufacturer and the operator of these.
That is
this
correct.
equipment,
They
correct?
built their own cars and they operated them as well.
Okay. Do you have any idea? Long ago, one of my first intern jobs was with Sperry. It used to be Sperry Univac. Is it just a separate company?
Different
Okay.
company. Totally.
All right. Yours, that one still survives.
And
Sperry
somebody
Univac
asked
is-
if I worked on the Siskiyou, and I pretty much ran on every piece of SP mainline and branch line track between Portland and Tucson. I only got east of Tucson once.
All right. John Hansky, is the signaling turned off during testing?
No, it's not. It acts weird, but it's not turned
Yeah.
off.
You may have to have the and at crossings, you said that can goof up the crossing gates and so
Correct.
on, correct? Okay.
Yeah.
All right. Let's see. This isn't really to you. Yes, the online meets will continue after COVID. Maybe not twice a month, but maybe once a month. We'll see how things go. But for right now, we got a lot of participants. We had a full house again today. We get lots of people watching the replays. As long as people are willing to present, because nobody wants to hear me talk for an hour, we'll keep doing them. So, Dave Hussman mentioned some Sperry cars were secondhand LV Lehigh Valley doodlebugs. So, all right. Well, we'll go ahead and I turned off the you can't unmute yourself bit. So if people have questions that they don't want to type, you can go ahead and unmute yourself. I'm going to go ahead and stop the recording though. Thank everybody for participating. Thank Dennis and Dale for presenting. And thank everybody for showing up. The next scheduled event will be in 2 weeks on the 21st. Watch your email, Facebook, website for connection information.